Good morning, my dear students. In our previous video lectures, we discussed about a very important Gauss law and its applications, and we finished the first chapter, that is electric charges and fields. And today's classes, we are going to discuss some of the important numericals of first chapter, that is electric charges and fields. Okay, and the JEE examination timetable is being displayed already. It is expected to be in the third week of July, and I really hope you guys are making use of the best use of these quarantine days, because you have sufficient time to get prepared for such examinations. So please make use of these days. Okay, 3-point charges of each of 10 microcoulomb plus 10 microcoulomb are placed at the vertices of an equilateral triangle of side 0.1 meter. Find the force on each charge. As we know, the Coulomb force is F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square, where Q1 Q2 is the product of magnitude of charge and R is what? It is distance between the two charges. Okay, so we shall solve this numerical. First we shall write the given things, given data. Here 3-point charges are there, of each of 10 microcoulomb are placed. It means all the three charges are having same magnitude. Okay, so Q1 Q2 Q3 is equal to plus 10 microcoulomb. All the three charges have same magnitude at the vertices of an equilateral triangle of side. Side means it is distance. Side it is 0.1 meter. All these are in SI unit only, no need to convert. So find the force on each charge. See here, this is equilateral triangle, and 10 microcoulomb, 10 microcoulomb, 10 microcoulomb. Okay, since the magnitudes are same, okay, so let us call it as A, B, C. Okay, the force on this 10 microcoulomb due to these two charges, or the force on this 10 microcoulomb due to these two charges, or the force on this 10 microcoulomb due to these two charges, it is going to be same because the magnitudes are same. And the force on this 10 microcoulomb due to this 10 microcoulomb and the force on this 10 microcoulomb due to this 10 microcoulomb, it is going to be same, because according to Coulomb force, the force exerted by the charge Q1 on Q2 and the force exerted by Q2 on Q1, both are going to be same. Okay, look at this diagram. This 10 microcoulomb will repulse this 10 microcoulomb, and this 10 microcoulomb also repulse this 10 microcoulomb, but let us take this one. See here, this 10 will repulse this 10. Okay, this is force on C due to A. Okay, and this 10 microcoulomb also repulse this 10 microcoulomb in this direction. This is F on C due to B, and this is FCA. Okay, and this angle is how much? This angle is going to be 60 degree, because this is also 60 degree. Okay, and the resultant of these two will be in this direction. Okay, so let us find out FCB and FCA. FCB is equal to 1 divided by 4 pi epsilon naught Q1 Q2. Q1 is how much? It is 10 into 10. Micro is there, therefore it is 10 into 10 to the power minus 6 into 10 into 10 to the power minus 6 divided by R square. R square means distance. It is distance 0.1, 0.1, it is 0.1. Therefore it is 0.1 into 0.1. Square is there, therefore. So FCB is equal to 9 into 10 to the power 9, because 1 divided by 4 pi epsilon naught value is 9 into 10 to the power 9. And see here, 10 to the power 1 is there, 10 to the power 1, it is 10 to the power 2, and 10 to the power minus 6 is it is 12. Therefore it is 10 to the power minus 10 divided by, it is 10 to the power minus 2. Okay, so FCB is equal to 9 into 10 to the power minus 1 into 10 to the power 2. Therefore it is 90 Newton. FCB is equal to, okay, and similarly FCA also, FCA will be 90 Newton. Okay, and resultant of FCB and FCA is, let us call it as FC, force on C charge. Okay, see, all the charges are actually having same 10 microcoulomb magnitude. And see here one more important point. In order to find out the resultant of these two, we shall use a formula, and that is FC is equal to under root FCB square plus FCA square plus 2 FCB FCA cos theta. Okay, but one trick is there. See here, these two magnitudes are actually same. When the magnitude of these two are same, then we can use one formula, that is FC is equal to 2F cos theta by 2. Okay, straight away you can apply this formula when the magnitudes are equal. Okay, see here, this F can be either FCB or FCA, no problem, because both are having same magnitude. This is very important trick. If we use this formula, we will get answer, but this is a lengthy process, so that we can use this formula. This is a trick. Okay, and see here, FC is equal to this FCB is how much? 90 Newton, and theta is angle between what and what? FCB and FCA. It is 60 degree. Okay, and 60 degree divided by 2 is 30, and cos 30 is how much? Cos 30 is 1 divided by 2, sorry, root 3 divided by 2. So 2 is cancelled, so it is 90 into root 3, so approximately it is 156 Newton. This is FC. Okay, so this was A actually. And remember, FA is equal to FB is equal to FC is equal to 156 Newton. It means force on this charge due to B and C, or force on B charge due to A and C, or force on C charge due to A and B are same, because all the charges are having same magnitude, that is 10 microcoulomb. Okay, and you can use this trick while the magnitudes of components are equal. Okay, this is second numerical. Two small spheres, each having a mass of 0.1 into 10 to the power minus 3 kg, are suspended from a point by threads 20 centimeter long. Here the length of the thread is given as 20 centimeter long. They are equally charged and they repel each other. Its meaning is the magnitude of charge is same, and the polarity is also same, then and then only they can repel each other to a distance of 24 centimeter. It means if two charges having same magnitude and same polarity, okay, if they brought closer, they repel each other and they get separated with a distance of how much? 24 centimeter. Okay, I mean the distance between two charges is given, it is 24 centimeter. What is the charge on each sphere? We are supposed to find out the magnitude of charge. Okay, see here, this is a rigid support. Okay, this is equilibrium position, and these are the spheres. This distance is given, and this distance is how much? 24 centimeter. Therefore this distance is 12 centimeter, and this distance is also 12 centimeter. The total distance between charges is, it is 24 centimeter. Let us call it as O, this as A, this as B, and this as C. Okay, see here, this sphere or this mass is experiencing various forces. See, This mass is experiencing force due to gravity and we call it as mg, and this is nothing but what? Weight. Okay, and this sphere is having a charge, let us call it as q, and this q charge is experiencing a repulsive force by another charge, okay, another charge q in this direction, and this force is called as what? Coulomb's force. Okay, and this thread has tension, okay, due to this mass. Okay, and this tension can be resolved into two components, one in this direction, another one in this direction. Okay, since this is theta, this is going to be theta. Okay, if this is tension is a vector quantity, therefore it is t cos theta, t sin theta, okay, t cos theta, and this one is t sin theta. Okay, so let us start its solution. Okay, so various forces. First one tension, and second one weight, and third one is Coulomb force. Okay, so first we shall calculate Coulomb force. Okay, that is F is equal to K Q1 Q2 divided by R square, and F is equal to K is 9 into 10 to the power 9, and Q1 is Q, and Q2 is also Q, therefore it is Q into Q is Q square, divided by R square is there. R is distance between the two charges, and distance between two charges is how much? 24 centimeter. Okay, therefore I can write it as 24 into 10 to the power minus 2, because it is in centimeter we shall convert it into meter, or I can write F is equal to 9 into 10 to the power 9 Q square divided by 24 into 24 into 10 to the power minus 4, or F is equal to 9 into 10 to the power 9 Q square divided by 24 into 24 into 10 to the power minus 4. So 3 3s are 3 8s are. Okay, so it is going to be 3 Q square. Okay, 10 to the power 9 is there, 10 to the power minus 4 is, therefore it is 10 to the power plus 13 divided by 24 8s are, or 3 1s are 3 8s are, it is 64. Okay, so Q square into 10 to the power 13 divided by 64 Newton. This is the force. Okay, and by using this diagram we can write it as, see, this t cos theta is balanced by mg and t sin theta is balanced by f. Therefore I can write it as t sin theta is equal to f and t cos theta is equal to mg. If I divide these two, t cancels and sin theta by cos theta is tan theta. Therefore tan theta is equal to f divided by mg. Okay, so f value we have already calculated, m mass we know, g value we know it is 10, and tan theta we are supposed to find out. With the help of this diagram I can try to find out the tan theta value. Tan theta is equal to opposite divided by base, and opposite is what? AC is opposite for theta and base is what? OC. Therefore it is AC divided by OC. AC value we know, this is how much? Length of the thread is 20 centimeter. It is 20 centimeter. But we don't know OC value. Okay, we can find out OC value with the help of Pythagoras Principle. Okay, from this triangle OAC. From triangle OAC, AO square is equal to AC square plus it is OC square, or OC square is equal to AO square minus AC. OC square is equal to AO square. AO square means this distance, it is 20 and 20 20 is a 400 minus AC is this distance and it is 12 centimeter, and 12 it is 144. Therefore it is 256, and 256 it is OC is equal to 16 centimeter. Therefore tan theta is equal to AC divided by OC. AC distance is how much? 12, and OC distance is 16. So 4 3s are 4 4s are. So I can write it as 3 divided by 4. So tan theta value is how much? It is 3 divided by 4. So F value we know, it is Q square into 10 to the power 13 divided by M. Mass is how much? 0.1 into 10 to the power minus 3. I can write it as 10 to the power minus 4. And G value we can take it as 10 is equal to 3 divided by 4. And Q square into 10 to the power 13 divided by 64 is there. So I will write here 64. Okay. So it is Q square into 10 to the power minus 4, 10. It is 10 to the power minus 3. And 10 to the power minus 3, 10 to the power 13. It is 10 to the power plus 16. Divided by 64 is equal to 3 divided by 4. So I will wash this. So Q square is equal to 3 into 64 divided by 4 into 10 to the power 16. So 4 1s are 4, 1s are 4, 6s are. So it is 48 into 10 to the power 16, or Q is equal to under root 48 into 10 to the power 16. Approximately I can write it as 6.9 into 10 to the power 8 Coulomb. The magnitude of charge is how much? It is 6.9 into 10 to the power 8 Coulomb. Okay. Since both the charges are having same magnitude, 6.9 into 10 to the power 8, and polarity is also same, they repel each other. Okay. Okay, this is our third numerical. See here. Point charges having values plus 10 microcoulomb, plus 20 microcoulomb and minus 20 microcoulomb are placed in air at the corners A, B and C of an equilateral triangle ABC having side 10 centimeter. Find the resultant force on charge A. This is numerical. See here, according to numerical, I will draw a diagram here. This is equilateral triangle, okay, and sides are A, B, C, and sides are having value how much? 10 centimeter. 10, 10, 10. And magnitudes are given. It is 10 microcoulomb, 20 microcoulomb, and C is minus 20 microcoulomb. Okay, look here. This 20 microcoulomb will repulse this 10 microcoulomb. Okay, in this direction. This is 10 microcoulomb actually, and let us call it as force on A due to B. And this 20 microcoulomb minus 20 microcoulomb will attract this 10 microcoulomb in this direction. Okay, and let us call it as force on A due to C. Okay, see here, one force is acting in this direction, another force is acting in this direction, and resultant of these two will be in this direction. Okay, let us call it as FA. We are supposed to find out FA. Okay, so first we shall calculate FAB. Solution. See here, force on A due to B, that is FAB is equal to K Q1 Q2, let us call it as Q1, this as Q2 and this as Q3. Q1 Q2 divided by R square, and K is 9 into 10 to the power 9. Since 1 divided by 4 pi epsilon naught is 9 into 10 to the power 9. Q1 is how much? 10 microcoulomb, and Q2 is how much? 20 microcoulomb. So 10 into 10 to the power minus 6, 20 into 10 to the power minus 6 divided by R square. R square is distance. So it is 10 into 10 to the power minus 2. It is in centimeter, we have to convert it into meter. Okay, so FAB is equal to 9 9 into 2, okay, 9 into 10 to the power 9, 10, okay, 10 to the power minus 6, 10 to the power minus 6, minus 6, minus 6, minus 12, minus 12 plus 9, it is minus 3, okay, minus 3 plus 10, it is minus 2. So 9 into 10 to the power minus 2 into 20 divided by 10 into 10 to the power minus 2 is how much? 10 to the power minus 1, square is there, therefore it is 10 to the power minus 2, okay. Minus 2 is cancelled, 9 into 20 is, okay, 180 Newton. So FAB is how much? 180 Newton. And similarly, force on A due to C, that is FAC, is equal to once again Q1 Q3 divided by R square. Q1 is K is how much? Once again 9 into 10 to the power 9. Q1 is how much? 10 into 10 to the power minus 6. And Q3 is how much? 20 into 10 to the power minus 6. No need to write its polarity, okay, as negative. And R square, distance is how much? 10 centimeter. Therefore it is once again 10 into 10 to the power minus 2 square, okay. See here, same to same is there, therefore I can write it as FAC is equal to 180 Newton. As in first numerical, I have already told you, if two forces, okay, are having same magnitude, then the resultant can be find out with the help of this formula. FA is equal to 2 FAC cos theta by 2. In place of FAC, you can take it as FAC also, FAB also, no problem, okay, because both are having same magnitude, 180, 180, okay. So this is easy method actually. No need to write as F is equal to under root F1 square plus F2 square plus 2 F1 F2 cos theta, okay. No need to find out this way because magnitude are same, both the forces are having same magnitude. Therefore 2, it is 180, and this theta is how much? See here, this is 60 degree, therefore this is also 60 degree, and see here, this is also 60 degree. So 60 plus 60 is 120. Therefore 120 divided by 2 is cos 60, and cos 60 is how much? 1 divided by 2. So 2 is cancelled. What is remaining? 180 Newton. This is force on A charge due to B and C. Okay. Okay, this is our fourth numerical. Consider three charges Q1, Q2 and Q3, each equal to Q. Okay, all the three charges are having value how much? Q. At the vertices of an equilateral triangle of side L. Equilateral triangle is there. The side of the triangle is how much? L. What is the force on charge Q placed at the centroid of the triangle? This is the question. Okay, see here, solution. For this we shall consider one triangle, equilateral triangle. This is triangle, okay, and see here, side is given, it is L, okay, and magnitude of the charges is how much? Q, Q, Q. Okay, let us call it as A, B, C. Okay, at the center one charge is there, and that charge is how much? Q. Okay, centroid of the triangle. See here, for AC I will draw a perpendicular, and for BC I will draw a perpendicular, and for AB I will draw a perpendicular this way. And this is what? Centroid. At this place they have placed a charge, that is Q. Let us call it as O. At O location Q charge is there, and on that Q charge, okay, the force due to A, B, C we are supposed to find out. Okay, please remember, if I place a charge Q here, this A charge will repel this charge in this direction. Okay, let us call it as force on, okay, Q, or force on O due to A. FOA we shall call it as. And similarly this B charge will also repel O in this direction. Let us call it as FOB. Similarly, this Q charge located at the centroid will also get repulsed by charge located at C in this direction, and this is FOC. Okay, see here, FOB and FOC, they have an angle of 120 degree. Okay, and one force is in this direction. Totally how many forces are there? 3 forces are there: FOC, FOB and FOA. Okay, so first we shall find out FOA. To find out FOA, we need this distance. Okay, what distance? AO. And distance AO is equal to BO is equal to, it is CO. Okay, so first we shall find out this total distance. Okay, let us call it as D, AD. Okay, so according to Pythagoras principle, I can write it as AB square is equal to BD square plus AD square. Okay, and AB square, we know AB square is how much? It is L. Therefore L square is equal to BD square is how much? BD square is L by 2. Therefore it is L square by 2. Sorry, L square by 4, because this distance is how much? L by 2. This distance is L by 2 plus AD square, or 3L square divided by 4 is equal to AD square, or AD is equal to root 3 L divided by 2. Okay, and sorry, this is not AD. AD is equal to root 3 L divided by 2, but this distance AO is 2/3 of AD. Therefore I can write it as AO is equal to 2/3 of AD, and 2/3 AD is how much? AD is root 3 by 2 into L. 2 is cancelled. Root 3 by 3 is 1 by root 3. Therefore it is L divided by root 3. AO is equal to, see, AO value is how much? L divided by root 3. And remember, AO, BO and CO both are same. Therefore I can write AO is equal to BO is equal to CO is equal to L divided by root 3. Okay, now we know the distance between the charges, so now we can calculate. Okay, so I will wash this. Okay, first point, that is force between, okay, force on O due to A, that is FOA is equal to K Q1 Q2 divided by R square is there. Q1 is Q, Q2 is capital Q. So QQ divided by R square. R square means L by root 3 square, that is L square. And I can write it as divided by 3 if this K 3K QQ divided by L square. And similarly, force on O due to B, that is FOB is equal to K Q1 Q2, that is Q into Q, Q into Q divided by R square. R square is this distance, that is BO. BO is equal to how much? It is L square divided by 3, or 3K Q divided by L square. Okay, and similarly force on O due to C charge, that is FOC is equal to K QQ divided by R square. R square is this distance CO, and CO is how much? L square divided by 3. Therefore it is 3K QQ divided by L square. Okay, so now we know all the 3 forces. But remember, this FOC and this FOB are acting in 2 different directions. By law of parallelogram, this is going to be the resultant. Okay, let us call it as okay, let us call it as F1. Okay, and F1 is equal to once again under root FOC square plus FOB square plus 2 FOB cos theta. Okay, but you can observe here FOC and FOB, they are having same magnitude. If they are having same magnitude, I can directly write it as 2F cos theta by 2. If this F is either FOB or FOC, no problem, because they are having same magnitude. Therefore F1 is equal to 2, I can choose any one among these two, 3 KQQ divided by L square, and cos theta by 2. This theta is how much? 120, and 120 divided by 2 is how much? 60, and cos 60 is 1 divided by 2. 2 is cancelled. What is remaining? F1 is equal to 3 KQQ divided by L square. This is remaining. Okay, and see here, okay, this F1 and this FOA, they are acting in two different directions, opposite directions. Therefore total resultant F is equal to FOA minus F1, because they are in different direction, exactly they are in opposite direction, this F1 and this FOA. Okay, and see here, FOA is how much? 3KQQ divided by L square, and F1 is how much? Once again 3KQQ divided by L square. Therefore net force is equal to how much? 0. It means the net force experienced by this capital Q charge located at the centroid of the triangle is how much? It is 0. Okay, so this is this is our next numerical. See here, a charge Q is placed at the center of line joining the two charges, each of magnitude Q. Prove that the system of charges will be in equilibrium if Q is equal to minus Q divided by 4. It means two charges are there. Okay, this is one charge Q, this is other charge Q. Okay, and these two charges are having same magnitude, and at the center of the line joining two charges, at the center means at this location, a small charge Q is placed. Okay, so this Q is placed. Let us call it as A, this as B, and this as O. Okay, O is center of AB. Okay, if this distance I considered as X, then this distance is also going to be X. The total distance is 2X. Okay, okay, solution. So this is given data actually, and solution. To be the system in equilibrium, net force acting on each charge must be 0. This is the condition actually. Net force acting on each charge must be equal to 0. Okay, therefore we shall consider this charge. Force on this B charge due to A and due to O, okay, must be equal. Okay, consider this charge Q, okay, at B. Consider the charge Q at B. We can write it as, see here, force due to this charge and force due to this charge, that is 1 divided by 4 pi epsilon naught QQ divided by this distance, that is 2x square, plus force due to this charge, that is 1 divided by 4 pi epsilon naught QQ divided by r square. R square means this distance, x square. This must be equal to what? 0. Okay, the force acting on this charge must be equal to what? 0 by these two charges. Okay, so 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, it becomes 0. QQ, it is q square, and 4x square plus QQ divided by x square is equal to 0. Okay, so q square, what is common here? Q divided by x square is common. Q divided by 4 plus q is equal to 0. Okay, so q divided by 4 plus q is equal to 0. Therefore q is equal to minus q divided by 4. This is the proof. Okay, it means at this location, okay, if charge q value is minus q by 4, then the whole system is going to be equal to